Hey guys! Welcome back to our YouTube channel. I am Raymond Gonzaga Egot.
And I am Chona J. Miranda.
And for today's video, we're gonna be playing a facts to facts about prime numbers. So in this video, you will able to learn about what is prime numbers, what are the prime numbers, and also we are going to provide a mathematical examples about prime numbers, and of course, we were able to give an example about a real life situation about prime numbers for you guys to comprehend well what is prime numbers. So, let's do this!
A prime number is a positive integer that can be divided evenly without leaving a remainder, only by the number 1 and itself. An integer is a number that is not decimal or a fraction. So the list of positive integers starts at 1 and counts up from there. A prime number that has one pair of factors. The number 1 is not a prime, so the first prime number is 2, which is also the only even prime number. So to contrast, a composite number has more than one pair of factors than prime numbers.
So, as what Miss Chuna said, that the prime numbers is just a two factors which is one in itself. So, in order to understand this, we will understand first what is factor. So, prime factor is different from prime factorization, wherein prime factor is a prime number used as a factor, while the prime factorization is the renaming number, the product of prime factors. So for example, 5, we all know that 5 is a prime numbers. So the prime factorization there is 1 times 5, that is called a product of prime factors. 1 times 5 and 5 times 1. And in contrary, Miss Chuna mentioned about composite numbers. Composite numbers is different from prime numbers because composite numbers are 4, 8, 16, 12, and so on. Because these numbers can be factored into different ways. Like for instance, for number 8 have different ways to factor. For example, 1 times 8, 8 times 1, 2 times 4, 4 times 2, and that number is belong to composite number, and it is not a prime number. Therefore, prime numbers is a natural number that is greater than 1. That is not a product of two smaller natural number. A natural number greater than 1 that is not prime called composite number. So now, let's proceed to the example, a mathematical example of prime numbers. So, in a number of 1 to 100, so what are the prime numbers? So, Miss Chuna, can you give some prime numbers from 1 to 100?
So the prime numbers from 1 to 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43.
So, we also have the prime numbers from 1 to 100 or 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So those are prime numbers from 1 to 100 because these numbers can only be factored into two ways, from 1 times the number itself and the number itself times 1. So that is why we call prime numbers. So now, let's proceed to the different types of prime numbers. We have the Fermat prime numbers and Mersenne prime numbers. So first, let's talk about Fermat primes. So first, let's define what is Fermat primes. So the prime numbers of the form 2 raised to k plus 1, where k is an element of z, are called Fermat primes. In mathematics, a Fermat number named after Pierre de Fermat. So, Fermat prime numbers have the theorem called lemma. So it states here that if n is a positive integer, therefore we have the a raised to n minus b raised to n is equal to a minus b, the summation of n minus 1 where k is equals to 0, and a raised to k, b raised to n minus 1 minus k. So now let's prove this theorem. So a minus b summation of n minus 1 where k is equal to 0 is a raised to k, b, and b raised to n minus 1 minus k is equal to summation of n minus 1 where k is equal to 0, a raised to k plus 1, b raised to n minus 1 is equal to a raised to n plus summation of n minus 1 where k is equals to 1 and a raised to k, b raised to n, and we come up with the result of a raised to n minus b raised to n. So that is the proving of the lemma theorem. So now me introduce to you the examples of Fermat primes. So first example is 2 raised to k plus 1 where k is 1, 2, 3, 4, and 5. So let's substitute the value of k. So we have 2 raised to 1 plus 1. So 2 raised to 1 is equal to 2 plus 1 is equal to 3, and 3 belongs to prime numbers. And then we have also the k is equal to 2, 2 raised to 2 plus 1, and then 2 raised to 2 is equal to 4 plus 1 is 5, and 5 is a prime numbers. And we have the 2 raised to 3 plus 1, and 2 raised to 3 is equal to 8 plus 1 is equal to 9, and 9 is not a prime numbers. It is a composite numbers because it has many ways to factor number 9, which is it can be 3 times 3, 9 times 1, and 1 times 9. And from the definition of prime numbers, it can only be factored into 2, 1 times itself and itself times 1. Now let's proceed to the k where k is equal to 4, and 2 raised to 4 plus 1. 2 raised to 4 is equal to 16 plus 1, 17, and 17 is a prime numbers. And for the last, 2 raised to 5 plus 1, and 2 raised to 5 is equal to 32 plus 1 is equal to 33, and 33 is a prime number. So among the value of k, 1, 2, 3, 4, 5, so there is one value of k that is not considered as prime, and it is the value of 3, because 2 raised to 3 is equal to 8 plus 1 is 9, so that is why it does not belong to prime numbers. So now let's proceed to another theorem. So it states that if 2 raised to k plus 1 is a prime and k is an element of z, the k is a power of 2. So prove. So since k is the power of 2, so we represent k is 2. So 2 raised to 2 plus 1, 2 raised to 2 is equal to 4 plus 1 is equal to 5, and 5 is a prime numbers. So that's the end of Fermat primes. So let's proceed to the Mersenne primes to be discussed by Miss Chula.
So Mersenne primes, the prime numbers of form 2k minus 1 where k is an element of z are called Mersenne primes. So where k is quantity of 1, 2, 3, 4, and 5. So example, 2 raised to the power of 1 minus 1 is equal to 1. And 2 raised to the power of 2 minus 1. So 2 raised to the power of 2 is 4, minus 1 is 3. So, and 2 raised to the power of 3 minus 1. So 2 raised to the power of 3 is 8, minus 1 is 7. minus 1. So 2 raised to the power of 4 is 16 minus 1 is equal to 15. Next is 2 raised to the power of 6 minus 1. So 2 raised to the power of 6 is 32 minus 1 is equal to 31. So the answer of all integers quantity 1, 2, 3, 4, and 5 are 1, 3, 7, 15, and 31. So where 1 and 15 is not prime numbers, because we all know that 15 can be factored by many ways. It can be 1 times 15, 15 times 1, 3 times 5, and 5 times 3.
But Miss Chona, why is that 1 is not considered as a prime number?
Mr. Raymond, 1 is not considered as a prime number because it does not meet the standards of prime numbers, which is state that prime numbers can be factored into 2 ways.
Okay.
So now let's proceed to the theorem of Mersenne prime. So 2k minus 1 is a prime where k is an element of z, then k is also a prime. Let's k is equal to an odd integer. So example of it is 2 raised to the power of 5 minus 1. So we all know that 2 raised to the power of 5 is 32 minus 1 is equal to 31, and 31 belongs to a prime number.
So therefore, in Mersenne prime numbers, we can only use integer, because if we will use even integer, it results composite number, and it does not meet the standards of prime numbers. So now, let's proceed to the real-life example of prime numbers.
A prime number are used in cryptography because they are difficult to factorize. This means that it is difficult to find the prime factors of a composite number without knowing the factors to begin with. This makes it difficult for someone to intercept a message and read it without the proper key. For example, a public key secures private information by locking it in a box whose handles are tightly clasped with a several hundred-digit combination lock. The box itself can be accessed by anyone, but the content inside it can't. While a thief may furtively steal the box, he can't unlock it without knowing the combination, without possessing the private key. This private key is only possessed by the sender and receiver of the content, the bank, and you, the proprietor of the credit card.